All right. Hey, everybody. Today's lesson is about 1.2 segment addition. So today we are going to solve for missing lengths using the segment addition postulate, and we're going to learn to identify congruent segments. So first of all, we got to talk about what it means to be congruent. We're going to see this word a lot in geometry. So congruent is kind of like equal, but for geometric objects. So like we can have segments that are congruent, we can have triangles that are congruent, we can have angles that are congruent. We're going to see this word a lot applied to different geometric elements. So for segments, so congruent segments, that means when two segments have the same length. Okay, so when two segments have the same length, they are considered congruent. So we're going to go over some notation here that we're going to be using to talk about lengths, to talk about segments in length, and to talk about congruent. So, for example, with our notation here, if I have a segment AB, that segment might be 5 centimeters long, let's say. And then we have a segment EF, and we'll say that that's also 5 centimeters. Some notation we would use here. Remember when we label a segment, it's like segment AB, like that. If I want to talk about the length of a segment, though, I just say AB without the line over the top equals 5, or 5 centimeters. Same thing goes for EF. I would label segment EF like that if I'm going to talk about my segment. But if I'm going to talk about the length of my segment, I would say EF equals 5 centimeters. Okay. So then I could say that AB and EF have the same length by going AB equals EF. So that's using the equal symbol. But if I want to talk about the segments being congruent, I have to use a different symbol. So if I say segment AB and segment EF, I can't just put an equal sign in between them because we're talking about congruent here. So I put the congruent symbol instead, which looks an awful lot like the equal sign. It's just an equal symbol with a squiggly line over the top. That is the congruent symbol. Congruent symbol. Okay. So if we're talking about things being congruent, that's the symbol that we use. I also usually use it as kind of a shorthand for congruent because writing congruent everywhere is a lot of writing. So you'll see this a lot in geometry and in your geometry notes. Okay. So an example of how we're going to be using congruent today is like this. If we have, let's say we have points A, B, C, and D, and we want to graph these points and decide, is AB congruent to CD? Okay, so to find out, we got to graph the points. So this is going to take us back to algebra, probably, is the last time you graphed a point. And I'm just going to draw a quick graph for myself here. I'm going to go out 5 in each direction. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and we do our best to make sure that these are spaced evenly apart, but we're going to make sure we also count and everything like that when we compare the lengths. So do your best with that. All right. Now what we got to do is plot the points. So A is the point 1, 1, so we're going to go over 1, up 1. And that's point A. Point B is 1, negative 5, so we go over 1 and down 5. And there's segment AB. And then we can just count to see how long it is. So we've got 1, 2, 3, 4, 5, 6. So this is 6 units long. Okay, then we're going to do the same thing for CD. So C is the point 3, 3, 2. So we go over to the right, 1, 2, 3, and then up 2. And there's point C. And then for point D, it's negative 1, 2, so we go to the left 1 and up 2. And there's point D. And now just visually, we can tell that these are probably not the same length, but let's count and check just in case. Go start at D, we go 1, 2, 3, 4. This is 4 units long, which is not the same as 6 units, so our answer is no, not congruent. Okay, so that's the context that we're going to be using congruent today. Okay, so that's the first part of the lesson. The next part is going to involve using something called the segment addition postulate. So let's go for that next. And move that so we can have more space. Here we go. Segment addition postulate. Okay, so the segment addition postulate is something that sounds very fancy to explain something that's a very simple idea. So the idea of the segment addition postulate, or the formal statement of it, is if point B is between points A and C, then AB plus BC equals AC. And so the picture that we get with this is we've got this line segment with 3 points on it. We know that B is between the other two, so B must be in the middle, and A and C are on the ends. So the idea is that this length, AB, plus this other shorter length, BC, is equal to the entire thing, AC. So if I add these two little ones together, we get the whole thing. So that's the main idea of the segment addition postulate. So there's a couple different ways that we are going to be using this. So we're going to go through probably 3 or 4 examples here. Okay, so example 1. We're going to start out with this picture, kind of like the one above. We have points P, Q, and R. And PQ is 7 centimeters and QR is 10 centimeters. And we want to know how long is PR. Okay. So this is probably the most simple example because we can see we have a small piece and a small piece. We should just add those together to get the entire thing because PR is the entire thing. So it's just 7 plus 10, which is 17 centimeters, and that would be our answer. So we just add them together. Okay. So the second example, we're going to step it up a level here. Not too big, but we're going to get the same kind of picture going where we've got, we'll call them A, R, and H for the points. And we have 14 inches, and we know the whole thing is 22 inches. And we want to know what is the length of RH. Okay, so for this one, since the small piece is one of the ones that's missing, you have a couple options here. You can, give this a variable and make it an equation and everything, or you can just think about it and go, okay, well, if the whole thing is 22 and this part is 14, why don't I just subtract that off? 22 minus 14 gives us 8. So our missing piece is 8 inches. Okay. So now we're going to step it up one more level and see a different type of problem here. Example number 3, we're going to bring in the algebra now. Break out the algebra. Okay, so putting on our algebra equation solving hats, here we go. We're going to get the same kind of picture going. We'll name them point L, point O, and point N. This part, LO, is 3x. This part, ON, is 2x plus 5. And the whole entire thing is 25. Okay. So now what we want to do is we need to set up an equation that will help us solve for x, because we want to know what is x, we want to know how long is LO, and how long is ON. Okay, so to do this, let's take a look back at our segment addition postulate example or diagram up here. We had the two small pieces adding together and setting it equal to the whole. That's where we're really going to use this now. Is if we go down here and we go, okay, one of the small pieces is LO, so that's 3x. The other small piece is 2x plus 5, so we're going to add those two things together. And we're going to set it equal to the whole thing, which is 25 in this case. Okay. So here we go. Now we just have to solve this equation. Let's first combine some like terms here. 3x and 2x is 5x. Then we want to subtract 5 from both sides to be left with 5x equals 20. Then we can divide by 5 on both sides to get x equals 4. So that's going to be part of our answer here, x equals 4. Then to find the other two missing pieces, I know LO is 3 times x, so I'm going to plug in x to LO and plug in x to ON. So 3 times 4 gives me 12. And then we can do 2 times 4 plus 5, which gives me 13. So there's my answers here. We have x equals 4, we have LO equals 12, and ON equals 13. Okay, so that was kind of our next level question. The last example is going to step it up one more level even than that. Okay, this one, they're not going to give us a picture here. We're going to make a picture. So here we go. For this one, we are told that E is between D and F. They tell us DE equals 4. EF equals 2x plus 10. And DF equals 3x plus 8. And we want to know the value of x, the value of DF, and the value of EF. Okay, so our job here is to draw a picture first to go with this. So if you are not given a picture like this, if they just tell you something like E is between D and F, then we need to draw a picture, because it will make our lives so much easier. Okay, so here we go. We are told that E is between D and F, so that means that D and F are on the ends, and that E is somewhere in between them. We know that DE is 4. Here's DE. We're going to put 4 there. We are told that EF is 2x plus 10. Here's EF. We're going to put 2x plus 10 there. And then DF is the whole thing, and it is 3x plus 8. Okay, so now that we have a picture, this looks a lot like example 3. Now we just need to set up an equation and solve it. So if you're watching this video, go ahead and pause for a moment and see if you can figure out what equation you would use to solve this, to figure out what x is. Okay, hopefully you paused it and figured out an equation. If you did not, or if you had trouble with that, keep watching. We're going to make an equation here. So just like with the last one where we took the 2 small pieces and added them together, we're going to do that same thing here. We're going to go 4 plus 2x plus 10. And then we're going to set it equal to the whole thing. The whole thing is 3x plus 8, so equals 3x plus 8. So if that's what you got for your equation, or something that looks similar to this, you could have also done 2x plus 10 plus 4. Doesn't matter either way. But if you got something like this for your equation, you're on the right track. Now we're just solving. So we have 2x plus 14 over here. And then the following steps that you do, there's not just one way to solve the equation. You could subtract 3x from both sides. You could subtract 2x from both sides. You could start with the constants instead. Doesn't really matter. I'm going to do it this way. I'm going to go subtract 2x from both sides. So that's gone there, and we're left with 14 on this side. And then we have 1x plus 8. Then I'm going to subtract 8 from both sides. And we are left with 6 equals x. Okay, so now we know what x is. X is 6. Now we need to figure out what df and ef are. So I know df is that 3x plus 8. So instead of 3x, I'm going to go 3 times 6 plus 8. And that gives me, let's see, 18 plus 8 gives me 26. And then I know EF is 2x plus 10. So instead of 2x, I'm going to go 2 times 6 plus 10, which gives me 12 plus 10 gives me 22. So there is our answer. DF is 26, EF is 22, and x equals 6. Okay, hopefully this was helpful. Your assignment for tonight is located in Google Classroom. So go ahead and get started on that. Don't forget to do the exit ticket. And if you have any questions, feel free to email me or come to office hours. All right, see you guys tomorrow.